Welcome back to my channel Kishore Sir Ki Pathshala. We are doing chapter metals and non-metals 10 Cbse. So last time we have seen physical properties of metals. So today we are going to see what are the physical properties of non-metals. So for that what we are going to do, we are going to collect samples of carbon, sulfur and iodine. Okay, these are what? Non-metals, right? And we are going to carry out the activities what we did for metals with the non-metals. Now what activities we carried out? If you remember, we carried out we have seen the hardness, right? We have checked about the malleability, the ductility, the electrical conductivity and the sonority for metals we did, right? So the same things we are going to see for non-metals as. So let's see for graphite. Graphite is what? It is a carbon, right? So if you see graphite, okay, surface is lustrous, okay, hardness, if you see it is a soft and malleable, you know that MSDW, what I taught you last time, malleable, that is my sheets, right? So can graphite be converted into sheets? No, right? Does it has a ductility? No, right? Okay. Does graphite conduct electricity? Yes, graphite conducts electricity. That's the reason graphite is used as electrodes in the electrochemical cells. Okay. Now let's come to the sonority. Okay, so do we get a sound with graphite? No, when we strike it. Let's see about coal. Coal, you'll see that it's non-lustrous. Okay, what about hardness? It's hard. So malleable, no. Ductility about coal is no. Electrical conductivity is no. Sonority is no. Okay, so now let's see about iodine. As such, you will see that it is lustrous, but hardness, malleability, ductility, electrical conductivity and sonority is not shown by iodine, right? So now let's see. So we have seen that physical properties of metals and non-metals as such. But with this, we can conclude that we cannot group elements according to their physical properties alone, because few of the metals will show us the sonority and few of the non-metals which will not show us the sonority as such, right? So there are many physical aspects in which there will be differentiation between these elements, right? So why? Because there are exception cases as such. So what we see here is that all metals except mercury exist as a solid at room temperature. So mercury, you will see that it will be liquid form. Okay, right? So we have observed the metals have what? High melting point and boiling point. Okay, high melting point will be there for metals, right? So what I see here is that gallium and cesium have very low melting points. So these are the exception case. Gallium and cesium are exception case. So these two metals will melt if you keep them in palm itself. Gallium less than 30 degrees is the melting point, right? So let's see for iodine. Iodine is what? Is a non-metal. Still it shows what? Luster. Okay, which is being shown by the metal. Carbon is a non-metal that can exist in different forms. So each form is called as allotrope. Okay, so diamond is an allotrope of carbon, which is the hardest material. See, hardness was shown by whom? By metals. Okay, which has got a very high melting and boiling point. Okay, this quality belongs to what? Metals. But what? Diamond is what? It's a non-metal. Now graphite, which is another allotrope of carbon, is a good conductor of electricity. Now this quality is also been shown by what? Metals. And alkali metals are there. Lithium, sodium, potassium. They are very soft, right? Now you have seen metals, they are hard. But lithium, sodium, potassium, they are very soft and can be easily cut with a knife. Also, they have low densities and low melting points. Now let's see classification of metals and non-metals based on their chemical properties. All right. So earlier we have seen how the physical properties we have seen for metals and non-metals. Now let's see for metals how this chemical properties are. All right. So what we are going to do? We are going to react these metals with oxygen and non-metals with oxygen. Okay. Let's see. Let us take a magnesium ribbon and let's burn this magnesium ribbon in air. Right. Now let's collect the ashes formed and dissolve them in water. And the resultant solution, let's try with both red and blue litmus paper. Alright. Okay, let's do that. Now, if you know that if you burn this strip of magnesium right in air, it is going to react with what? It is going to react with oxygen. Right, this is going to react with oxygen, and what you are going to get here, you see magnesium is there. When burned in air, it reacts with oxygen and you get magnesium oxide. Right. Okay. And this magnesium oxide, then we need to dissolve in water. Right. So the resultant what we get magnesium hydroxide, MgOH twice. Right. Okay. So we are getting this. So what we are going to do? We are going to test this magnesium hydroxide with my blue and red litmus paper. Right. Okay. Now let's see what happens with this. If you see this, if we take blue litmus paper, there will be no change. Right. There will be no change as such. But what will happen with the red litmus paper? Red litmus paper will turn blue. Okay. Red litmus paper will turn blue, and it shows us that it is nothing but basic in nature. So this is nothing but what? My basic oxide. Alright. Okay. So basic oxide what I got. Right? Right, basic oxide, that is, so magnesium hydroxide is basic oxide as such. So now let's burn sulfur powder. Okay, let's place sulfur powder in a test tube and let's burn it, and let's collect the fumes produced. Right. Okay, then add some water to the above test tube and shake. Okay, then let's test with the blue and red litmus paper. So you will see that here blue litmus paper will turn red. Okay, what it shows? It shows that acidic sulfurous acid. Okay, here you see sulfur reacts with oxygen to sulfur dioxide. Sulfur dioxide, when reacts with water, it gives me H2SO3, that is sulfurous acid. Right. So this is what my acidic oxide. Okay. So this is my acidic oxide as such. What happens when metals are burned in air? Right. So you'll see that which metal burns easily. It's sodium is a metal which will burn very easily. So what flame color do you observe when metal is burned? You'll see that a yellowish flame is there. Right. How does the metal surface appear after burning? You'll see that silver whitish will be the surface. Okay. Now let's arrange the metal in the decreasing order of their reactivity towards oxygen. Alright. Okay. So sodium will be the most reactive. Then you have magnesium, aluminium, zinc, iron, lead, and copper as such. Okay. Are the products soluble in water? Okay, whatever products we get, we will get what? We'll get oxide. Right. So in that you'll see that sodium oxide is soluble in water, others are insoluble. Right. Now let's see how the reaction takes place. Almost all metals, they combine with oxygen to form their corresponding oxides. Okay, so metal plus oxygen gives me metal oxide. This is a general reaction. Okay, this is my general reaction. So metal plus oxygen gives me metal oxide, right? So when copper is heated in air, it will combine with oxygen to form copper to oxide, of that is a black oxide will be there, right? So this is my copper to oxide, right? Okay, so here you see copper, we have taken oxygen, we have got copper oxide, okay, which is black in color. Aluminium forms aluminium oxide. Here you see aluminium is there, it reacts with oxygen, it forms aluminium oxide, right? Student, I'm sure you know how to balance the given chemical reaction. This is what my Al2O3, right? Now you'll see that some metal oxides such as aluminium oxide, now aluminium oxide is zinc oxide, okay, these show what, both acidic as well as basic behavior. Okay, why so? Let us see. Such metal oxide reacts with both acid and bases to produce salt and water, right? Therefore, they are known as amphoteric oxide, right? The metal oxide which reacts with both, it reacts with acid as well as base, and to give what, salt and water, are known as amphoteric oxide, right? So let's see aluminium oxide, how it reacts. Okay, here you see aluminium oxide is reacting with hydrochloric acid, and what you are getting, you are getting a salt, which is what, aluminium chloride, and water, right? So means here you see it's acting like a base plus acid, right? Base plus acid gives me salt and water. Here you see it is acting like a acid, and this is my base, right? Okay, to give salt and water. So it's behaving like both, like base and acid, right? So that's the reason it is nothing but it is my amphoteric oxide, right? It is my amphoteric oxide. So we have seen that metal oxides which are insoluble in water, right? But some, they dissolve in water, are alkalis. Okay, so here you see sodium oxide and potassium oxide, they dissolve in water to produce alkalis as such, right? Here you see Na2O, that is my sodium oxide, they dissolve in water to give me what, sodium hydroxide, which is an alkali, right? Okay, see a potassium oxide with water to give me potassium hydroxide, okay, which is an alkali. So students, I'm sure you have understood today's topic, where we have seen some chemical reactions happening with metals and non-metals. So kindly like, share and subscribe my channel Kishore Sir Ki Pathshala for more informative videos.